in this video, we're going to be looking at additional constructions. Now, however, we won't go into a lot of detail about constructions because usually the software, like the Geometry Sketchpad and GeoGebra, are used in dealing with constructions, which we will not discuss in this particular course. But we will talk about briefly in this particular video that deals with additional constructions, some of the properties of angle bisectors and the incenter of a triangle. Okay, so in this particular situation, let's say you were asked to construct an altitude from vertex A and you were given triangle ABC. Now in the last video we did talk about what an altitude is. It is the segment that is perpendicular from a vertex to the line containing the opposite side of the triangle. So in this case here, line segment AD would be the altitude of this particular triangle, because it's starting from the vertex and the line segment is perpendicular to the opposite side of that particular triangle. Okay, and then next, if you want to do an altitude with an obtuse triangle, then in this case it would be on the outside, which means you're going to have to extend one of the sides of this triangle here. Like in this case, BC, and this should be triangle ABC. So BC would be extended, and then you have to do the construction there. But in this case, the altitude can be on the outside, starting from the vertex, and it's going to be perpendicular to the opposite side of that triangle. So again, line segment AD would be the altitude of that particular obtuse triangle. Now with the right triangle, it won't be necessary, because notice that AB, side AB, would be the altitude itself, because you have the vertex and it's perpendicular to side BC because of the right angle there, because you have a right triangle in this case here. So already you do have an altitude for that right triangle, in this case side AB. Now let's look at some properties of angle bisectors here. Now, an angle bisector is a ray that separates the line it separates the angle into two equal angles. Okay? So in this case here, one of the properties is this. Any point P on an angle bisector is equidistant from the sides of that angle. So let's say ray AP is your angle bisector. Starts at the vertex and it separates angle XPY into two equal angles here. Now, take a look. This distance from P to D has the same distance from P to E. Okay? So any point called P on the angle bisector is going to have the same distance from the sides of that angle. And any point that is equidistant from the sides of an angle has to be on the angle bisector of the angle. So if point P has the same distance to D as to E, then point P must be on the angle bisector. Okay, so the length of PD is congruent to the length of PE, because those distances are the same. Okay, now here we're going to talk about the incenter of a triangle briefly. The angle bisectors of a triangle are concurrent, meaning that they intersect at a single point, and that point of intersection has a special name called the incenter. And those three distances from the point of intersection to the sides are equal. So in this case, this circle is inscribed in the triangle. And if we did constructions of the angle bisectors for each of those vertices of that triangle, like for angle A and for angle B, that point of intersection is called the incenter. So point P is the incenter. And the distance from the point of intersection to the sides, like for PM, PK, PN, actually they're all radiuses, so they're going to be equal. So that means here, if you look at MC, CN, they're equal. Okay, so that's basically what the incenter of a triangle looks like. You're just getting the point of the intersection of all the angle bisectors. Okay, so that will conclude this particular short video on additional constructions.